Hey there, science enthusiasts! Ever wondered what makes up everything around us? From the chair you're sitting on to the device you're using to read this, it all boils down to tiny particles called atoms. Atoms are like the building blocks of matter, incredibly small, yet fundamental to our universe. Think of it this way. Imagine a delicious cake. You can keep cutting the cake into smaller and smaller pieces, but eventually, you'll reach a point where you can't cut it any further without changing what it's made of. That's like an atom, the smallest unit of an element that still retains the properties of that element. Atoms are incredibly small. To give you an idea, a single strand of your hair is about 1,000,000 atoms wide. Yet, these tiny particles are buzzing with activity, thanks to even tinier particles within them called subatomic particles. These subatomic particles, protons, neutrons, and electrons, hold the key to understanding the atom's identity and behavior. Join me as we delve deeper into the fascinating world of atomic structure. Let's embark on a journey to the center of an atom, where we find the nucleus. The nucleus is like the atom's control center, compact and dense, containing two types of subatomic particles, protons and neutrons. Protons are positively charged particles, giving the nucleus an overall positive charge. Neutrons, on the other hand, carry no charge, hence the name neutron. Together, protons and neutrons make up most of the atom's mass. Imagine the nucleus as a marble at the center of a giant football field. The football field represents the entire atom, and the marble represents the tiny nucleus. This analogy highlights just how much empty space exists within an atom. The number of protons in an atom's nucleus is what determines its atomic number, a unique identifier for each element. For example, hydrogen, the simplest element, has an atomic number of 1, meaning it has 1 proton in its nucleus. Now let's talk about the third musketeer of the subatomic world, the electron. Electrons are negatively charged particles that constantly move around the nucleus in regions called electron shells or energy levels. Think of electrons as tiny race cars whizzing around a racetrack, with the nucleus at the center. These electron shells are like different lanes on the racetrack, each with a specific energy level. Electrons are much lighter than protons and neutrons, and are constantly in motion. This constant movement creates a cloud of negative charge around the nucleus, balancing out the positive charge of the protons. This balance is what keeps atoms stable. The arrangement of electrons in different electron shells determines how an atom interacts with other atoms and forms chemical bonds. It's like a delicate dance, with electrons dictating the steps and forming the beautiful molecules that make up our world. Now here's where things get interesting. Isotopes. You see, while all atoms of a particular element have the same number of protons, they can have different numbers of neutrons. These atomic twins are called isotopes. For example, carbon, the element that forms the backbone of life as we know it, has 2 stable isotopes, carbon-12 and carbon-14. Both have 6 protons, but carbon-12 has 6 neutrons, while carbon-14 has 8 neutrons. This difference in neutrons affects the atom's mass number, which is the total number of protons and neutrons in the nucleus. Isotopes of an element have the same atomic number but different mass numbers. Isotopes have unique properties that scientists can use in various fields. For instance, carbon-14 dating helps determine the age of ancient artifacts, while certain isotopes are used in medicine for diagnosis and treatment. Understanding atomic structure is crucial to comprehending the world around us. It helps us explain chemical reactions, the behavior of matter, and even the vastness of the universe.